On a winter night in 1610, Galileo Galilei aimed a handmade telescope at Jupiter. Next to the planet, he noticed tiny lights that changed position from night to night. Those lights were moons orbiting Jupiter, proof the sky had more than one center. If that is true, then the old map of the cosmos is missing a page. A question hangs there in the dark. If Earth is moving, what else must move with it, including our confidence, of course? Galileo did not set out to win an argument. He began as a man looking for a measurement that would not flatter anyone. This is the story of how looking carefully became a form of courage. It is also a reminder that reality does not take appeals. Galileo was born in Pisa in 1564 and grew up largely in and around Florence. His father, Vincenzo, was a musician and theorist who distrusted borrowed certainty. As a student, Galileo was steered toward medicine because it sounded practical. Mathematics felt less practical and more true, so he switched. A famous story says he watched a lamp swing in a cathedral and sensed a steady rhythm. Whether or not the scene happened exactly as told, the idea points to his gift for recognizing patterns. Pendulums fascinated him, along with the promise of regular motion. If nature repeats, you can count it. Aristotle's claim that heavier objects fall faster did not satisfy him. Reputation, Galileo suspected, is not a force of nature. Later, legend placed him atop the Leaning Tower of Pisa, dropping unequal weights for a crowd. What matters is that he treated motion as something to test, not something to inherit. In his early career, he gained a name for clear lectures and sharp questions. He also gained the burden of supporting a family, which focuses the mind wonderfully. In 1592, he took a better post at the University of Padua. Padua would become his workshop for nearly 2 decades. Padua was busy, practical, and crowded with capable hands. Galileo taught mathematics there from 1592 to 1610, and he thrived. In lecture halls, he broke problems into steps and assumptions. In private, he kept asking what motion looks like when no one is trying to win an argument. Chalk dust clung to his cuffs and fingertips by the end of a day. It is hard to feel like a philosopher when you look like a flower merchant. Instruments mattered to him as much as ideas. When your math helps a navigator, your landlord becomes strangely patient. The military compass, measuring tools, and other devices kept his life afloat. They also bought him time for useless questions, which are often the best kind. Rolling balls, falling weights, and slanted planes became his teachers. Motion turned into numbers, and numbers turned into predictions. Projectiles drew arcs instead of straight lines. Nature, he found, likes curves more than slogans. He would later describe a simple truth about relative motion. In a smoothly moving ship's cabin, everyday actions look the same as if the ship was still. The point was not wordplay, it was discipline. If you want truth, you separate what you feel from what you can measure. By 1609, Galileo had a reputation for making hard things plain. Then a rumor arrived that made the sky testable. News reached Italy of a Dutch viewing tube that pulled distant objects close. Galileo did not invent it, but he improved it quickly. With careful lens work, magnification climbed. In Venice, he demonstrated the telescope, and the city immediately saw its value. Venice admired the view, then admired the advantage. Cities have always been quick studies when distance is involved. Most people used early telescopes for ships and fortifications. Galileo pointed his at the heavens, which was like using a key to open a door no one had noticed. On the moon, he saw a jagged border between light and shadow. Shadows implied mountains and craters, not a flawless sphere. In the Milky Way, the pale band broke into countless stars. What seemed like a soft cloud became depth. In the winter of 1609 and 1610, he followed the moving lights near Jupiter. Night after night, they kept returning as if on a schedule. The conclusion was unavoidable because the pattern would not stop. Jupiter had moons, and Earth had competition. In March 1610, he published Sidereus Nuncius, the Starry Messenger. Europe reacted quickly because the evidence could be repeated by anyone with glass and patience. Venus soon joined the testimony when it showed phases like the Moon. The simplest explanation was that Venus orbits the Sun. Sunspots drifted and changed across the solar disk. Even the Sun wore marks that moved, and perfection quietly resigned. Galileo was not collecting curiosities. He was building a case, one observation at a time. Copernicus had proposed a moving Earth decades earlier. Galileo made the proposal harder to dismiss by showing what the telescope revealed. His observations did not solve every detail. They did something more disruptive, which was to make the old model feel cramped. In his later, most public writings, he wrote so educated readers outside universities could follow. Choosing Italian over academic Latin widened the audience and, predictably, the anxiety. Galileo believed faith and nature could not truly contradict. He argued that when observation is clear, interpretation should be careful. In 1616, Roman authorities ruled heliocentrism could not be taught as established fact, and Copernicus's book was suspended until corrected. Galileo was instructed not to hold or defend the doctrine, and he avoided teaching it as established fact for years. A physical proof that Earth moves still tempted him. His tide argument was wrong, which is a useful reminder that cleverness is not the same as correctness. Yet the method remained sturdy. Claims were to be anchored to phenomena that other observers could check. By the 1630s, Galileo was famous across Europe. Fame did not make him safer, it made him visible. In 1632, he published Dialogue concerning the two chief world systems. It staged a conversation between competing cosmic pictures, and it was far from dull. The dialogue is witty, and the Copernican side is stronger on the page. One character is named Simplicio, which is not exactly an invitation to calm debate. The book drew scrutiny from the Inquisition. In 1633, Galileo was tried and judged vehemently suspect of heresy. He was compelled to recant, and his sentence was imprisonment that soon became house arrest. The universe did not change, but his freedom did. Galileo lived under restriction near Florence, at Arcetri. He was aging and still thinking in experiments. His eyesight deteriorated until he was effectively blind. The man who sharpened Europe's vision could no longer see his own notes. Work continued anyway, guided by memory and conversation. Motion, acceleration, and strength of materials returned to center stage. In 1638, his final major book was published in Leiden as Two New Sciences. It gathered decades of insight into falling, projectiles, and the mathematics of change. Uniform acceleration and parabolic motion were laid out with a new clarity. Physics became something you can compute, not merely admire. Galileo died in 1642, still under the shadow of his trial. His method, however, had already escaped the room. Galileo's story is often flattened into a simple clash between science and religion. It is more accurate to call it a collision between observation and a world built to protect certainty. He was brilliant, and sometimes prickly, he also had the quiet endurance to keep working when applause turned into surveillance. His greatest invention was not the telescope. It was a habit of mind where questions outrank titles and evidence outranks pride. Later, Isaac Newton would take these measured motions and extend them into a wider set of laws. The spark was the same, a refusal to let tradition do the measuring for you. When you look closely, the universe does not become smaller. It becomes more intimate, like a truth you can finally name. From a handmade lens to a moving earth, the sky became evidence. You're always welcome here. At Illumentary,